Hi everyone, today we're solving the longest increasing subsequence problem. This is a classic question. In this video, I'll show you the dynamic programming approach. In this problem, we're asked to find the length of the longest strictly increasing subsequence. So for this array of numbers, the longest increasing subsequence is made up by 1, 2, and 4, giving us a total length of 3. Notice that the numbers included in the subsequence aren't necessarily consecutive. First, let's see why a brute force approach fails. Let's just take our initial array of numbers as an example and see what the decision tree for all possible subsequences looks like. There are in total 16 possibilities, making the algorithm exponential, specifically O of 2 to the n in the worst case. Instead, we'll use a dynamic programming approach. So we define dp at index I as the length of the longest increasing subsequence ending at this index. Each element starts as its own longest increasing subsequence. That's why we initialize our dp array with ones. Then, for each I, we check all previous numbers using another pointer j. If the previous numbers at j is less than the current number at I, then we update our dp array, because that means that the subsequence is increasing. So the recurrence we'll be using to fill our dp array is the following. dp of I is updated to be the maximum of its current value and 1 plus dp of j, for all j where nums of j is less than nums of I. Remember that this is the condition that ensures the subsequence is actually increasing. We're now going to see a full example on how to fill the dp array. So this is our array of numbers, and we're going to initialize our dp array with ones, because each element is a valid subsequence of length 1 on its own. We're also going to be using two pointers, I and j. So let's start with dp at index 0. This is just going to be 1, because we don't have any previous elements coming before, and the only subsequence we can make has only one element. Let's now calculate dp at index 1. To do this, we're going to check all numbers that come before. So we're now starting to use our pointer j, which starts at 0. We ask ourselves, is the number I'm comparing less than 2? Yes, indeed, 1 is less than 2. So we have to update our dp array, because that means that our subsequence is increasing. dp at index 1 is just going to be the maximum between what we currently have at index 1, which is 1, and 1 plus dp at index j, in this case 0. This is just 2, and the maximum between 1 and 2 is 2. Let's now calculate dp at index 2. So again, we have to check for all numbers that come before. So j starts at 1, so we compare, is 2 less than 1? No, of course not. So we do nothing. Now we decrease j once more, and we compare it again. Is 1 less than 1? No. So again, we do nothing. We do not update our dp array. Finally, we calculate dp at index 3. So j starts at 2, and we compare. Is 1 less than 4? Yes. Then we gotta update dp at index 3. Which is just going to be the maximum between what we currently have at this index, which is 1, and 1 plus dp at index j, in this case 2. So the maximum between 1 and 2 is 2. We decrease j once more, so j is now 1. 2 is less than 4, so we have to update our array, and it's going to be the maximum between what we currently have, now it's 2, and 1 plus dp at index j, 1 in this case. That gives us 3, and the maximum between 2 and 3 is just 3. We still have one more when j is equal to 0. 1 is less than 4. We take the maximum between our current value 3 and 1 plus dp at 0. That gives us 3. At the end of this process, here's what our dp array looks like. We can see the length of the longest increasing subsequence ending at each position. To get the final answer, we simply take the maximum value in this array, which in this case is 3. That's our solution. Let's now look at the code. We can see that time complexity in the worst case is big O of n squared. Meanwhile, space complexity is just big O of n, since this is the space that occupies the DP array. So that is it for my first video. Thank you so much for watching, and if you liked it or found it helpful, feel free to let me know. I would really appreciate any feedback or support as I get started. See you next time.